Good morning. We're back. So one of the videos we just shot a little bit ago was how to calculate the percent composition. So if I want to know how many girls are in the room, how many boys are in the room, if I had 20 girls out of 30 people, that'd be 20 divided by 30. That gives me 66% girls. That means 33% would have been guys. So we did that. That's another video. What if you were given the percent compositions of something and were asked, then what's the formula? Can you go backwards? That's what today is. So how to calculate an empirical formula. It's basically 3 steps. Step 1 is you're going to divide each of the percentages by their molar mass. I'll show you how to do this in just a sec. You then determine the ratio, and how you do that is you simply divide by the smallest value, and then you write the formula. So this is a pretty simple step. I want to show you how to do it. So if I were to give you said, hey, some compound out there that we don't know the formula is 30.4% nitrogen and is 69.6% oxygen. What's the formula? Is it NO? Is it N2O5? Is it NO2? Is it NO3? Like, what's the formula? How do we know? So step 1 says divide each percent by their molar mass. So if I've got 30.4% nitrogen, I'm going to take just the number 30.4 and I'm going to divide by the molar mass of nitrogen. Not N2, just nitrogen. Okay, so nitrogen's mass is 14 right off the periodic table. And oxygen's mass is 16 off the periodic table. So step 1, divide each percent by their molar mass. Nitrogen's molar mass is 14. I know I have 30.4% of it, so I'm going to take these two numbers and divide. 30.4 divided by 14 is 2.17. Okay, 69.6 divided by 16 is 4.35. Okay, step 1 complete. Now, time for step 2. Step 2 says we have to find the ratios. In order to do that, basically we divide by the smallest value. So you got to ask yourself, which number is smaller? Is 2.17 or 4.35 smaller? Exactly, 2.17 is smaller. So what you do is you divide each of those by the smallest value. So I'm going to divide 2.17 by 2.17 and 4.35 by 2.17. Well, any number divided by itself is 1. And just to be very thorough, I've got 4.35, so I did the math right here. I'm going to divide that now, divided by 2.17. Okay, with a little bit of change there, I mean, there's some leftovers, but roughly we're at 2. Tripped over my cord. Those are my ratios, 1 and 2. So for every 1 nitrogen, there's going to be 2 oxygens. So the empirical formula is then going to be N, 1 of them, O, 2 of them. And there's my empirical formula calculated by percents, from percents. Okay, let me set up one more problem. I'm going to pause this real quick and set up another example. So give me a hot second. Okay, so second example. You were given 82.4% nitrogen and you were given 17.6% hydrogen. What is the formula? So step 1, divide each by their molar mass. Molar mass of nitrogen, we just did, was 14. Molar mass of hydrogen is 1. So 82.4 divided by 14 is 5.89. Rounding that off to 2 decimals, I guess. And this one would be 17.6. Okay, so step 1 is complete. Step 2, find the ratios, divide by the smallest. Which number is smaller? It's going to be this one, the 5.89. 5.89 divided by itself is 1. 17.6 divided by 5.89 is 2.99. we're gonna round that to 3 because it's pretty close. It was like, you see that? That's pretty close to 3. I mean, 2.988, that's close enough because we did some rounding there. That's gonna be 3. So again, if I've got 1 of these and 3 of those, that means I got 1 of those and 3 of those. So NH3. So our empirical formula would be NH3. For every 1 soda, or for every 1 nitrogen we have 3 hydrogens to go along with it. Okay? That is calculating empirical formulas. So again, we'll have some practice problems for you coming up in the future. Talk to you guys soon.